Lesson 24 is about the multiplicative property of equality. In Lesson 23 we learned about the additive property of equality, where we can add the same number to both sides of an equation, and that does not change the value or the solution to the equation. It just changes the way it looks. In a similar way, let's say we had three variables, A, B, and C, and they were all real numbers, and that A was equal to B. Now, we could multiply both sides of that equation by C, and we would not change the equation. We would not change its solution. The left side would still equal the right side. We would just change the way it looks. For example, if A and B were both equal to 2 and C was equal to 3, we'd have 3 times 2 is equal to 2 times 3. We did not change the solution to that equation. We did not change the truth or falsity of it. The left side still equals the right side. It's still a true equation. We just changed the way it looks. We use the multiplicative property of equality in algebra in a similar way that we use the additive property, in that we use it to try to isolate a variable in an equation to help us figure out the solution to that equation. For example, look at practice problem A. 2/3 x equals 16. Now, we need to try to figure out what value of x would make that left side equal to the right side. We can use our multiplicative property of equality to do this. Now, we see that 2/3 is a coefficient of x, or a factor of that left side, 2/3 times x. So we can use the multiplicative property here. We could divide. That's like the inverse of division, and it works the same way as multiplication in the multiplicative property rule. We could divide or multiply in order to get rid of that 2/3. Well, if you remember back in lesson 11, we talked about what the reciprocal of a number was, and if we multiplied the reciprocal by its original number, that equals 1. And so let's go ahead and do that. On the left, we can multiply 2/3 by its reciprocal, 3/2. And our multiplicative property of equality tells us we have to multiply the other side by the same thing, 3/2. That way we won't change the equation, we'll just change the way it looks. And so now on the left we have 3/2 times 2/3, which equals 1. And so we can just cancel that out. And instead of saying 1x on the left, we'll just say x. And then on the right side, think of that 16 as a fraction if you need to. Think of it as 16/1. We can simplify here. 16/2 is the same thing as 8/1. And so we end up with 8 times 3 is 24/1, or just 24. And so x equals 24. That is the root for that equation. And so we used the multiplicative property there. We multiplied both sides by the same number. We didn't change the solution. We just changed the way that equation looked. It allowed us to isolate the x by itself and solve for x. Figure out the solution to that equation. Look at practice problem B. 2 1/3 x equals 18. Again, we have a factor there that 2 1/3 is a coefficient of x. We need to get rid of that, so we can use our multiplicative property to do that. But first, let's change that mixed number, 2 1/3, let's change that to an improper fraction. And so we'll have 7/3 times x is equal to 18. And so then what we need to do next is multiply both sides by the inverse of 7/3, or the reciprocal of 7/3, which would be 3/7. Okay, so on the left now, 3/7 times 7/3, we know that that's just equal to 1, and so that all cancels out. And on the right we have x equals 18 times 3/7. Now, we try to simplify that. We can think of 18 as 18/1. There's really nothing that's going to simplify there, and so we'll have 54/7. That's what 18 times 3 is equal to, is 54/7. Now, we don't want to leave our answer as an improper fraction there, so let's change it to a mixed number. 7 goes into 54 7 times. And then we would have 5 as a remainder, so that would be 5/7. 7 and 5/7. And so we would say that 7 and 5/7 satisfies that equation. Look at practice problem C. We have x divided by 1/3 equals 60. So basically the variable x is in the numerator, 1/3 is in the denominator. Anytime you have a problem like that where you have like a numerator and then the denominator is a fraction or vice versa, that's called a complex fraction. And it can make things a little bit confusing. But let's just try to use our multiplicative property to isolate x. So what we could do here to get rid of that 1/3, since it's in the denominator, is we could multiply by 1/3. Multiply both sides by 1/3. And let's just think about this. On the left side, we could consider that 1/3 as 1/3 over 1. And so we see that we have 1/3 over 1/3, and so those 1/3 fractions cancel on the left. On the right, we have 60 times 1/3, or 60 divided by 3. So x is equal to 20. And so x equals 20 is the solution to that equation. Let's do one more problem. This one we have is similar to C, and we have a fraction in the denominator. It's just a mixed number this time. X divided by 4 1/5 equals 10. So as always, what we've been doing on these problems when we have a mixed number like that is to change it to an improper fraction first, and then we'll think about what to do. So let's go ahead and do that. We would have x over 21/5. That's equal to 10. And just like we did in practice problem D, we can multiply both sides by 21/5, and that should cancel, or that will cancel, the 21/5 on the left. And so we can think of that 21/5 on the left side, 21/5 times x over 21/5. Think of that as over 1, and those 21/5 cancel. And then on the right side, think of the 10. If you need to, you don't have to do it this way, but if you get confused with fractions, you can always think of a whole number as over 1, change it to a fraction, and then we can see we have 10 over 1 times 21 over 5. 10 over 5 would simplify to 2 over 1, and then on the left we just end up with x is equal to 2 times 21 is 42 over 1 times 1, so that's just going to equal 42. So x equals 42. Now I had kind of said earlier in problem A that you can divide both sides by the same number. It's the same idea as multiplying both sides by the same number. And just real quick, let me do a little problem. 3x equals 12. To solve that, we could divide both sides by 3. And that would cancel the 3's on the left, and we would end up with x is equal to 12 over 3, or 4. So if you're faced with a problem like that, you can just do division. You can divide both sides by the same number. It's the same idea as multiplying both sides by the same number. You don't change the equation. You don't change its solution. You just change the way the equation looks. Okay, well that's all for lesson 24.